What's up, kids? This is Mr. Carlson, C Squared Mathematics, and we are on our last lesson of Unit 2, and that is solve rational exponential equations. So we're going to put what we learned last week, radicals in rational expressions, and put them in equations. We already did yesterday. What we did was we took radicals and put them into actual equations, but we're also now going to take rational expressions and put them into equations, rational exponential expressions, and put them into equations. That's what we're going to be doing today. But before we get that, we're going to go through 2 questions on bell work. More than likely questions you'll see on the homework quiz. That's next. The objective essential question, what are we actually learning today? Why is it important? And then we're going to get to our actual lesson with the summary, closure, and homework. So for bell work, I have these 2 questions. Go ahead and write them down, pause the video, because I'm going to get to the next screen and work on them. Okay, so this is a rather beastly question only because it had the 2 radicals in here and we sort of solved it at the end of the last lesson. Okay, but I'm going to do it again. What I'm going to do here is I'm going to take one of these radicals and put it onto one of the other sides of the equation, only so that we have at least one radical already isolated completely. And that radical would be the radical x plus 6. So this is going to be isolated on the left side, equals, and then this is going to be 1 plus radical x minus 5. Now what I can do is I can square both sides. I'm going to square everything on this side. So now this goes poofy. The square and the square root go poofy. So x plus 6 equals, when I square this, it's going to be everything. So it's going to be double of, which means I'm going to duplicate it as such. Okay, so when I duplicate this, I am going to FOIL this junk out. So 1 times 1 is 1, and then this times 1 is the exact same thing. So that's not too bad. I'm loving life. This right here, same thing. So radical x minus 5. And then when I take these 2 together, remember, if square root of 3 times square root of 3 is 3, or square root of 5 times square root of 5 is 5. If they're the exact same base with the same index, all I take is the base, so plus x minus 5. And then I'm done. That's all I need to do. Of course, I still have x plus 6 chilling on this side. Let's start simplifying this stuff out in blue. Now, I notice I have an x right here and an x right here. That goes poofy. I have a 1 and then a negative 5 that I can combine. So that's actually going to be negative 4. And then this is a coefficient of 1. That's a coefficient of 1. So this is plus 2, because 1 plus 1 is 2, and then x minus 5. Okay, and then I still have a 6 chilling on this side. Now what I'm going to do is I'm going to add that 4 over, so this is going to be 10 equals, and then 2 radical x minus 5. Let's move it over here. I'm going to divide by 2. So again, I'm going to isolate the radical again. I want to isolate the radical again. So we sort of isolated it here, but now I'm going to do the whole process over again. So now this is going to be 5. 10 times divided by 2 is 5. And then this is going to be radical, and then x minus 5. I'm going to square both sides. So this equals 25. And then on the other side, right side, is x minus 5. Add the 5 over. So that is 30 equals x. So this so far is my tentative solution. When I check this, and we can check this, that's what I'm going to do. I'm going to plug it in to check it. So this is going to be 30 and then plus 60 minus, plug in my original equation, 30, and then minus 5, and then this equals 1. So this is going to be 36, so square root of 36 is 6. That's going to be 25, square root of 25 is 5. And so it does look like it checks out, which means 30 is my answer. Okay? So that's how you do that question. Make sure you are checking all proposed solutions. If you don't check, you might get a wrong answer, and you can't just put it in there because Math Excel will mark it wrong. And then you'll be like, what the junk? And then you'll be like, partial credit, and I'll be like, because we should get it right the first time. Let's erase. This one is not as difficult because it doesn't have the 2 square roots. So we're going to solve it accordingly. This is going to be 2x plus 15. This is going to be x plus 6. I'm going to square both sides in parentheses because they are your very best friend. That goes poofy. This is going to be 2x plus 15. This is going to be, after I FOIL it all out, x squared plus 12x plus 36. I'm going to subtract this stuff over because it's just like a quadratic. The inverse of a radical is a quadratic. I need to solve it like a quadratic, which means I need to set it equal to 0 on one side. So this is x squared. I minus the 2x over, so that's going to be plus 10x, minus the 15 over, so that's going to be 21. Yeah, 21. Factors of 21 that somehow, some way add up to 10. So this is going to be x plus 7 and then x plus 3. Of course, this is equal 0, which means my actual answers are x equals -7 and -3. Now, let's check them. When I check them, I need to plug in -7 first. So 2 times -7 is -14, and then plus 15 minus 6 equals -7. This is my first check. This is going to be 1, so square root of 1 is 1. So 1 minus 6, and then -7. And this actually equals -5. So that means 7 is not my answer. So I'm going to go over here, and I'm going to say nope. And so now my next one, I'm going to check that, -3. So let's plug that in. So 2 times -3 is -6. 2 times -3 is -6 plus 15, and then minus 6, and then -3. Yep. So this is actually going to be 9. So square root of 9 is 3 minus 3, and this becomes -3. So -3 or minus 6, that becomes -3. That is -3 right here, -3 right there. Sorry, is -3. So that means my actual answer is -3. That is my final checked solution. Okay, I know I went through those fast because I want enough time for the actual lesson here. So if you need to replay it again, pause the video if you need to take a picture. I'm going to erase, and let's get you started on the homework quiz. This will actually be 3 questions this time, 25 minutes. So open notes. When you're done, make sure you review your answers because you could maybe get some partial credit if you forgot like a negative or a digit or something. You can ask for some partial credit. And then begin your last lesson of Unit 2. Solve rational exponents or exponential equations. Solve rational, exponential, or exponent equations. Okay? So after you're done with that, you're going to come back here and do the objective and essential question, solve rational exponential equations. How do I solve them? And how can I solve them using rational exponents? Now this is great. I love this. This is one of my, when I was doing student teaching, one of my mentor teachers had this on her wall, almost similar to this. And it was so great. When you square something like that, it does not mean x to the 4th plus 9. This right here, what it means is x squared plus 3 times x squared plus 3. That's what it means. So then x squared times x squared is x to the 4th. This is plus 3x squared plus 3x squared plus 9. So x to the 4th plus 9. Plus 6. Whoopsie. Plus 6x squared plus 9. Now that would be the actual correct way to do it. Okay, and same thing here. When you actually square root this, you can't really square root anything right here. Like you can't even solve that at all. There's nothing you can do to simplify that down, unfortunately. So that's not the right answer. Why do I bring this up? Because we're going to be doing a lot of similar problems like this in the next couple examples. And every single time you make a mathematical error like that, you're slicing off my pinky. Okay, you're killing my cat. You're killing a puppy, and that puppy looks pretty cute actually. So don't do that. Okay, do not do that. Be careful of your math. All right. My steps. First things first. Just like with radicals, just like with absolute values, you want to isolate not the x, but isolate the expression with the exponent. After that, you're going to raise both sides to the reciprocal. This by far is the most important step, so keep that in mind. Raise both sides to the reciprocal of the exponent, solve, and check. We want to still check. I'll probably only show you the check for the first couple examples, and then I'm just going to tell you which one it is. Most of the time, I will be honest with you, most of the time you will always have the right answer. So most of the time when I say check, I I really do mean like we still need to check. It's not optional. Just like my last slide, my last video for radical equations. Just like with radical equations, it's not optional here. So we still need to check. However, I will be candid with you. Most of the time, you will get a right answer if you do the math correctly. So let's get started. Isolate the expression with the exponent. X has an exponent. It's isolated. Fantastic. Done. Raise both sides to the reciprocal of the exponent. What's the reciprocal of 3/2? That is 2 all over 3. Okay, that's the reciprocal. What happens is I need to do what I do to one side, I need to do to the other, the whole of the other. So that's what I'm going to do. Now, what happens here? Well, I'll ask you kids, what is x to the 3 divided by 2 power to the power of 2 all over 3? What happens? Well, this is a product to a, or power to a power, which means they multiply, which means I have 3/2 times 2 all over 3, which means what happens to the 2's? Poofy. What happens to the 3's? Poofy. What do I have left? 0? No, I have 1. I have 1 because 3 all over 2 times 2 all over 3 does not equal 0. It equals 1. And so this will be x to the 1 power, which is exactly what I want. See how simple that is? Perfect. Boom. Now what do I have here? Well, my index is always my denominator of the exponent. So that means cube root of 27. And then squared. Now, could you put the squared with the 27? Of course. That's another way you could write it, just like what I showed you last week during rational expressions, rational exponents. You could definitely do that. However, it's easier to do it this way because what's the cube root of 27? It is 3. And then I square that, which is just 9. So x equals 9. And then I'm done. Now, if I could check this, I could plug x for 9 in. So watch. I have 9 and then 3/2 equals 27. This is my original equation. I just plug 9 in. Now that means the square root of 9. So I'm going to do the square root of 9 and then I'm going to cube that afterwards. That's what that means when I go back and forth it. You can plug that in your calculator as well. You can plug that into decimals if you want as well. And then you can equal 27. I don't care. But this is probably the easiest way to do it. Square root of 9 is 3. Okay, I was thinking the square. But it is 3, and then cube that, it is 27. So 27 does equal 27, which is exactly what we wanted. So that means it's my correct answer. 9 is my correct answer. Boom. You starting to see how these are very, very similar to radical equations. They are extremely similar to radical equations. So if you're starting to pick up that vibe, then good vibe picking up, okay? Good job at picking up that vibe because you're correct. Now this one, it's not isolated, so I need to isolate it. Subtract the 14 over. So I have 14 as such. I still need to isolate it, so divide the 7 because that's multiplied in between. Opposite of multiplication is division. Now what I have is x to the 5/3 power equals 2. So far, so good? Now what I can do, since it's isolated now, I'm going to take both sides to the reciprocal of the exponent. 5/3, the reciprocal is 3/5. So 3/5. Those go poofy, so I'm just left with x equals 2 to the 3/5 power. There's really nothing you can do here because this is just like the 5th root of 2 to the 3rd. So you can rewrite this as the 5th root of 2 to the 3rd power, which is the same thing as the 5th root of 8. Like you can rewrite it like that if you really want to. It does not matter. Okay, or you can just keep it like this. I'm going to keep it like this right here, and I'm going to check it for you, okay? So I'm going to check it for you. So this is 7, and then what was my x? 2 to the 3/5 power. 2 to the 5/3 power minus 14 equals 0. That's what I had. Okay, so I'm just substituting that in. What happens to the exponents? They go poofy, of course, the 3's and the 5's. So I really just have 7 times 2 minus 14 equals 0. Well, that's 14 minus 14 equals 0, which is, of course, 0 equals 0, which is true. 0 does equal 0. Nothing does equal nothing, which means this is my final answer. Depending on what math Excel wants, they may want you to put it in radical form. They may want you to keep it in rational exponent form. It does not matter. Just make sure you read the little blue instructions underneath, and then you'll be fine. Okay? Let's go to town. Let's go to town on these. I'm going to stop the checking. Okay? I'm not going to check it anymore. I'm just going to tell you if it actually does check out. Okay? And then we should be solid. It is X isolated. So now what I'm going to do is I'm going to switch this up to be 2/3. What I do to one side, I do to the other. Those go poofy. So now what I'm left with is X minus 5 equals the cube root of 64 and then squared. Now, I could do 64 squared underneath the cube root, but that's really obnoxious. I mean, 64 squared is a big number, right? I don't want to do that. It's way easier to do the cube root of 64, which is just 4. So now I just have 4 squared, which of course is just 16. And then I'm going to have X minus 5 on the bottom. So X equals, I minus the 5 over to the other side, so that becomes, or add the 5 over to the other side, so that becomes 21. That is my final answer. And now when I do check it in, it does check out, as you'll see right here. Perfect. So complicated thing right here is that when you're plugging 21 in, because that was my answer, 21, when you're plugging 21 in, 21 minus 5 is 16. The square root, that's a square because it's 3/2. So the index is the 2 here, which means square root. So I actually put that index there, even though we normally don't write that. The square, I did put that there. So square root of 16 is 4. And then cubed is 64. Okay, moving on. Let's go to town. So this one's going to be rather interesting. So I would definitely mark this because there's something slightly different than the other ones that we just did. And that is, of course, number 3. When we solve the remaining equation, I will have what we call plus or minus solutions. Now, why is that? Because the other examples, what we had was an index of 3, an index of like 5, or something like that. With this one, we have an index when I isolate this, which is true, and then when I raise both sides to the power of the reciprocal, or the reciprocal power, I have 3 halves. Now here's the difference. Before I would have 2 all over 3 or 2 all over 5 with my reciprocal exponent. Here I have 3 halves. That means my index is a square root, which means I have 2 solutions. I have a plus or minus solution because it is a square root. Whenever I introduce a square root, you have to have a plus or minus solution. I've started this because, guys, guess what? This is on your test. This one right here is going to be on your test. I know it is. And always, without doubt, I know there are some of you who will forget this. You'll only have one solution. You'll forget to do the plus or minus. So yes, the 2's go poofy, and the 3's go poofy. I'm left with X minus 2. But right here, what I have is the square root of 16 cubed. When I take the square root of 16, okay? When I take the square root of 16, especially when I introduce it here, guess what? That means I have plus or minus 4 cubed. So that means I have 2 solutions here, okay? I have, number 1, X minus 2 equals positive 4 cubed. But I also have number 2, X minus 2 equals negative 4 cubed. I have 2 solutions, guys. You have to pay attention to that, okay? So what's positive 4 cubed? Well, that's just 64. And then X minus 2, which means when I add the 2 over, X equals 66. Okay? And then right here, that's going to be negative 64. And so when I add the 2 over, that actually equals negative 62. Okay, so X equals negative 62. So I actually have 2 solutions here, 66 and negative 62. I have 2 solutions here. That's vitally important. Vitally important. So now, what happens when I check it? I'm going to show you right now. So notice down here, notice my first one I plug in 66. When I start solving it to the power of 2 all over 3 is the same thing as the cube root of 64 squared. So cube root of 64 is 4, and then I square that, it's 16. So that's what I have right there. Okay. Now, on this one, I have negative 62 minus 2. Negative 62 minus 2 is negative 64 to the 2/3 power. That gives me negative 64, but when I cube it, I have negative 4. Just plug that into decimals, you get the same thing. Calculator it. It's totally the exact same thing. All you have to do is plug that in the calculator right here. Plug in the calculator. Same thing. Okay. You can plug that whole thing actually in the calculator and I'll pop this out. But right here, negative 4, square that, 16. It's the exact same thing. So both of these are my answer. But I guarantee you, most of you will forget one or the other. You will only take the square root of 16, which will be 4, and you'll only get this answer. Most of you will only get that answer, the positive side. Very few of you will probably get this one, the negative 62, which is a real shame, even though I'm going through it right now. Okay? This one is going to be on your test, I guarantee it. So review it. Let's erase that, and let's get to one of our last couple examples here. Okay? I have this example and then an application question, and then we'll be done. This one looks a little bit scarier because it has just the x squared minus x minus 4, but it's really not. You just add the 3 over. So I have x squared minus x minus 4, 3/4 power equals. Add the 3 over, that's 8. So now what I'm going to do is I'm going to take in red here, take this whole thing to the 4/3 power. Same thing here, 4/3 power. The 4's and the 3 go poofy, so I'm left with x squared minus x minus 4. No rational exponent involved. So this right here is the cube root of 8 and then to the 4th power. The cube root of 8 is just 2 to the 4th power, which is the same thing as 16. So now what I have is x squared minus x minus 4, because that just gets brought down. And since it's a quadratic, I need to actually set it equal to 0 and solve it like a quadratic. So x squared minus x. I subtract that over, that's negative 20 equals 0. So now what I can do is do my basic template right here. Factors of negative 20 that somehow, some way add up to negative 1 right here, the negative 1x. That's just going to be minus 5 and positive 4. Minus 5 times positive 4 give me negative 20, but negative 5 plus 4 give me negative 1. So that means my answer is x equals 5 and then minus 4. Those are my answers. Okay. When I check it, it looks like this. So I have, for the first one, I have this. For the second one, I have that. So you can go ahead and follow that. I'm not going to explain it any more than I have in the previous slides. I think it's very self-explanatory. So just follow along, but it does check out right here. 5 equals 5, 5 equals 5. So these are my true answers. Okay. Sweet action. So let's erase this and let's get to our last and final slide, applications. The formula J equals 2.3 times radical X plus 28 models the percentage of full-time college students with jobs X years after 1975. Use the formula to project when 39.5% of full-time college students will have a job. So how do I actually solve this? Well, there's a couple of ways to actually solve this, to be honest with you, but I'm going to solve it the way I think is the easiest. I take 39.5% because J is the percentage. This models the percentage. So I take 39.5, that percent, equals my formula that I'm given. You could solve it using decimals as well, but I think this is just way faster. Okay, now what I do is I take the 28 and minus it over. So 39.5 minus 28 is 11.5 equals 2.3 radical X. I want to divide by 2.3, divide by 2.3. That goes poofy. And then actually, when I plug this into the calculator, surprisingly and shockingly, I actually get I actually get 5, which is pretty remarkable, actually. I actually get 5. And then this is just going to be radical x. I square both sides, square both sides. That, of course, goes poofy, so I'm left with x equals 25. Now, this is not my actual answer, and some of you may think it actually is. But the problem is they want us to use this formula to project the year when students will have 39.5% of students will have a full-time job. Now, what does x actually equal? Well, x is years after 1975. That's the key. Okay, so if 25 is my x and x is years after 1975, I take 1975 plus what I found for x, which is 25. This equals in the year 2000. Okay, in the year 2000, 39.5% of full-time college students will have jobs. Okay, in the year 2000. All right, and that's pretty great. Yes? So if I want to know 60%, I would do 60% right here and see which jobs, which year had 69% or 60% of full-time college students will have a full-time job. Okay? So that's the application question. I'm not going to explain it anymore. The summary is very straightforward. I learned 2 things. Number 1, I learned how to solve equations with rational exponents. And I also learned how to solve application problems. This is very basic application problems. We only went through one by rational exponential equations. Okay, this is the last lesson. This is the very last lesson of Unit 2. So in the next couple of days, you won't be having any videos. It's just Unit 2 review and the Unit 2 test. No video attached. Just watch these videos. If you need additional help, go through the previous videos of Unit 2, and then you'll be fine. Okay? Make sure you are working on the Unit 2 review and check any missing work as much as possible so that you can get that turned in. Okay? But until then, I am Mr. Carlson. This is C Squared Mathematics. See you in Unit 3 next week.